Hello, everyone. We're excited to be presenting our work over the past couple months on Brazil's subsidized housing and violent crime. So, the Minha Casa Minha Vida, or My House My Life program in Brazil, aims to address the growing housing crisis in the country, but a lot of research and reports have highlighted issues related to increased violent crime in these areas, given that they might be more vulnerable since they tend to be built in more rural, remote areas where land is cheaper. And so, we want to look into some of the factors that are contributing to violence in these neighborhoods. So for our project, we narrowed the scope to look specifically at the Salvador region in Bahia State, Brazil. Shown on these maps here, this is a good test case for the rest of the nation, given that we have access to a lot of geolocated data and there are also many public housing units. So the main goal for us is to develop a strong predictive model that will be able to predict homicides from geographical information and covariates that we were provided with. We were given a very long list of about 480 covariates. So part of our early research was figuring out which ones are important and relevant. And we want to ultimately be able to use our findings to identify potential locations that are at risk of contributing to increased homicides. So we worked with three main data sets. Firstly, a housing data file that had information on the coordinates for the locations. And we also had that list of covariates with demographical information about the population from the 2010 Brazil census. And lastly, we had a homicide data set from the year 2022, which meant that our approach had a spatial focus rather than temporal. So this map here shows homicide rates in the Salvador metro region by census tract with the blue dots representing where housing locations are. And you can see for some of the census tracts, like the pink one on the top, it looks like housing units sort of encircle these pink regions. And we thought that was an interesting observation.
So looking into some of the relevant covariates that we are going to use to build up the model, we noticed a trend that along the eastern coast of Salvador, we see that there tends to be higher resources and higher representations of variables that we were given, such as income. And then looking at race, we see that there's a higher proportion of Black residents and a higher homicide rate in the more rural inland areas, whereas there's a lower homicide rate and a higher proportion of white residents along the eastern coast of Salvador. And then lastly, looking at literacy rate, which we identified as a representation for education level, we noticed a similar trend as income where there is a higher education level or literacy rate along those eastern tracts. So all this data was really helpful in building up our models, but there were some concerns that we needed to address. So for one, we only have homicide data from 2022, so it was harder to make causal interpretations, and we had to be careful with generalizing. Additionally, some of the census tract had very low population count data, so we needed to employ spatial smoothing within our models.
Yeah, so looking ahead at some of our modeling, we started with a generalized linear model predicting homicide rate from different covariates. So this is from the Poisson family because we're predicting counts and rates. We passed all of our covariates through a regularization method using elastic net regularization in order to select covariates that have higher predictive power. And this regularization method is known to promote sparsity and handle multicollinearity in the covariates, which are both desired traits for us. We used a cross-validation framework in order to select our final model here. So from our predicted homicide rates, we have our predicted rates on the left and the true rate on the right. And we see in general that the model is effective at identifying census tracts that have non-zero homicide rates and like finding those areas. But we also see it underpredicts the high homicide rate census tracts for the most part. But that's not necessarily a problem if we're just using this model primarily to identify underlying trends in the covariates and socioeconomic factors. Looking ahead, we also tried to incorporate the spatial information into this generalized linear model. And so we conducted a spatial lag of relevant covariates using each census tract's neighboring values, given also the covariates identified from our EDA and the previous model. So we found some success using a zero inflated Poisson model because we know a lot of the homicide rates for our census tracts are zero. So we used lagged population covariates to predict the census tracts with zero rates, and we used other covariates to predict the non-zero rates. Specifically, we saw that lagged nominal income, distance to MCMV housing units, and different household indicators helped to predict the non-zero rates, whereas the lagged demographic variables such as race and literacy helped to predict zero rates.
The other model type that we used was a spatially lagged model. It's in essence, it's the same as a linear model, but it includes a spatial lag term, which captures the influence of neighboring census tracts. We also included covariates that the GLM identified as being strong predictors, including distance to nearest housing unit and also other household indicators. Here we generated heat maps from the spatial lag model predictions compared to the graph on the right-hand side, which is the predictions from the GLM. Overall, we found that the spatial model tended to really fixate on outliers, especially the ones in the Northwest region, while the GLM tended to highlight the central areas. We also, in our residual analysis, we observed that the GLM model tends to underpredict, while the spatial lag model has a tendency to overpredict. In the next slide, we have recommended census tracts from each model. The spatial lag model had a tendency to identify smaller census tracts as having lower homicide rates, while the GLM tended to highlight these larger regions and identify them as having lower homicide rates. A couple suggestions for client use. If the goal is more related to urban planning, the GLM is a little bit better for more broader regions, and the spatial lag model is better for a bit more targeted areas. For policy decision support, we found that GLM is best for areas where socioeconomic factors are key drivers of crime, while for the spatial lag model, it was more ideal for areas where crime was more spatially dependent. Our next slide includes our next steps for the project, which include where future extensions of the project would include testing the results in other major cities in Brazil and exploring alternative smoothing methods. Thank you so much for listening.